Okay, so we are back. Before I start, I'm going to let a few more people get in here. I'm doing good, thank you for asking. So we are back. Alright. So let me get my view in frame here. And I could adjust the microscope capture view. Okay. So, first thing, SMCs. Do not replace it unless you know it's bad. Messing with the SMC can make you regret it. A common thing is PP bus G3 auto be 12.23 volts. That does not mean the SMC is bad. That could be caused by a bad ISL as well. That could be caused by the chip that enables the SMC, U5010, I think. Might be different on some boards. That chip can be bad. You could have a leaking capacitor on SMC on-off L line, and that can cause PP bus voltage to be low. So don't replace this chip unless you know it's bad. If you don't know if it's bad, think and make sure you know it's bad before you replace it. This chip can fail. It doesn't always fail, but it definitely fails. But this chip is a pain to replace. It's a pain to reball. So I'm going to show you a way. I may fail on the stream. I don't know. That you could replace this chip without having to reball it. Do not attempt to do this. Do not attempt to change a chip this way if you do not have a good hot air station. With a cheap hot air station, you will not be able to do it this way. So if you have a decent hot air station, you should be able to do it this way. So basically what we're going to do is put a lot of flux on the chip and lift it up straight up off the board so we do not disturb the balls on the board. It should work. It may not work. We will see. So the first thing to do when changing this chip this way is, of course, remove the edge bonding. Use a lower temp on your hot air. So I'm going to set my hot air at max air, but I want to go about 100 Celsius, a very low temperature. And I'm using the biggest nozzle. Those are the quick station. I'm using the biggest nozzle available, which is the 8mm. That's pretty much a nozzle I recommend for all types of rework. So what we're going to do is take this edge bonding off right here. So I want to just preheat this. I want better tweezers for this, and these tweezers are bent. So what mic did I get? Someone was kind enough to send me the Samsung mic, so that was really nice. If you guys are wondering what I'm doing now, I'm straightening my tweezers because they are bent, and bent tweezers are no good. There we go. Actually, I'm going to go a little hotter. I want like 120. If you go too hot, you're going to melt the edge bonding, and then all that stuff is going to go under the chip, and I'm looking for another pair of tweezers that I used that is lost. I always lose the one pair of tweezers I need, but we'll just use these. So I'm going to take the edge bonding off. We're going to get this area nice and warm. We don't want hot, we just want warm. And we want to make sure we get this off in I really want my Hakko CHP 3SA tweezers, but where could I put them? Oh, here they are. They're hidden. Okay, so this will make this easier. And of course it's not going to come out like I want it to. This is probably one of the worst parts about changing an SMC is this dumb stuff. What I'm trying to do is get it lifted a little bit so the hot air can go under it. This board is sliding. I'm going to try and keep your chat window over here so I can see it. Okay. If we do not get this off in one, like I just failed at, we will not be able to take the chip off right, but I think we're good. Yeah, we're good. So I removed my rubber mat and I moved it over there, but I'm seriously considering bringing it back because the board doesn't like to slide on that, and it slides like crazy on my desk. Yeah, you know what? Excuse me for 1 second. I'm getting that mat back because this is a pain. Yeah, I moved the mat because I thought it would give me a little more working area, but no, it's just a real pain without it. Okay. Yes, it is a Samsung Go mic. Let's try this again. So now the board won't slide around. That'll make it easier. Quick tip when removing the edge bonding is poke the edges of it, because what you're going to do is you're going to break the seal between the edge bonding and the board, and it will make it easier to lift. But this is going to be a pain, of course, because I'm live streaming it. Sometimes this edge bonding comes off so easy, and then times like this that it doesn't. It's a real pain. Come on. There we go. Got a little bit more right here, but it's not going to hurt anything. There we go. Okay, so all the edge bonding is off. So, now that the edge bonding is off, what we could do, let me make sure that this is, there we go. Okay, so now we need a lot of flux. So Line the chip with a good amount of flux. Do not be, just put it on there. You don't need to worry about using too much. Now when we solder it, when we put it back on, it's a different story. So just put loads of flux around the chip. Now we're going to set our hot air to 430 degrees Celsius and 120 liters of air a minute. Let it get nice and hot, and then we're going to get our other tweezers. It's important to use tweezers that can grip the chip properly, because if we do not, basically the goal is we need to pull the chip straight up. So use tweezers that can fit around the chip. So we're going to preheat until we see the flux is burned away except for right around the chip. So just heat. One second here before I suffocate from the smoke. Sorry about that. So keep preheating. Until you see the flux is heated away except for right around the chip. We're not there yet. And we want to make sure the chip jiggles before we lift it. So I'm going to just gently tap it. And once I see it's liquid on all the balls, so it's almost there, we're going to grab it and we're going to pull it straight up. Like that. And there's the chip. So we did not disturb any of the solder balls. The solder balls are still perfectly on the board. We are going to double check on the chip to make sure there's no bridges on it. And I'm just going to do this visually. Chip looks good. Looks like there's no bridges. And I'm going to double check, make sure I didn't knock anything off. So now that we have 96 perfect balls left on the board, and now what we're going to do is get some flux and put the flux on the balls right here. We're going to get our hot air and we're going to make these balls liquid again. What do you mean upside down? Let me see. Okay, I see what you guys are saying. Let me fix that. Properties. Wait. There, that should be, yeah, that's better. Okay. Lower the angle. I can't really much, so that's about as good as it's going to get. Sorry about that. I want to make these balls liquid again just because some of them have flat tops where we lifted the chip. So I want to make all these balls liquid again using the lower air. But I might, I'll just go high. I'm going to make these perfectly round again. So now what I'm going to do is go around and make sure, just double check that all the balls are there, and they are. Beautiful. Okay, now here's the hard part. The chip will want to fly away. So here's what we're going to do, and this is how I always solder micro BGAs. Do not go too heavy on the flux. Do not use more flux than you need. We're just going to get a little bit of flux on there. We do not need much at all, because the flux under the chip isn't going to be in the direct path of the hot air, and it's not going to burn away. So we don't put too much flux. So we're going to get our chip now, and we're going to go 430 Celsius and 30% air, 30 liters of air. So that's a lot less airflow, and the chip does not need to be lined up perfect. It's got to be a little close, but surface tension will pull it into place. Just try and line it up best you can. And we're going to move in on it, and we're gonna take a low airflow, and we're not going to move in on it right away because it'll blow the chip away. We're gonna heat it until we see it fall into place, and then we're gonna move out with hot air, put more flux, and use a higher airflow and reflow it. So I don't want it to blow away, so I'm gonna start it from far away. This chip is tough. You're not gonna burn this chip. Well, you can if you know, but it's one of the harder chips to burn. So don't worry about being too hot or too long on it, as this chip can take it. So you know, start from far away. See, it's starting to move. We don't want it to move. Just start from far away. We don't want this to blow away. So just we'll see it fall into place. Not yet. Quite soldered yet. Some of the balls are liquid and some are not. That needs to go. There, so the chip is in place. Make double check. Yep, the chip is in place. So we're gonna move out. I'm going to double check and look at it because I don't want it to blow away on me. So I'm going to tilt the board and look under my microscope. Yeah, the chip is in place, not quite flowed. It's partially flowed, but now at least what we can do is more flux and a higher airflow and flow it perfectly into place. So we're going to do the same thing we did when we were moving it. Max air 430, start far away until the flux is bubbled away, and then we'll move in on it until we can see it moving around on the solder balls. Camera might not pick that up, but if you're doing this, you'll know what I mean when you see it happen. So you see it's jiggling now a little bit. You maybe kind of see that on the camera, but the chip is dancing back and forth. Make sure, keep the heat on there just a second. There, it's done. So the chip is now soldered perfectly. Let me let it cool down a little bit, and make sure those flux fumes get sucked away because the board is still smoking. Okay, so we didn't reball this chip. We had no need to reball it. It's just a matter of technique on removing the chip. If you could do this like I did, you should not have to you should not have to reball the chip. The main thing is do not pull the chip up until you know all the balls are liquid. If you pull the chip up before all the balls are liquid, you'll get a dry pad, then it'll be junk and you'll have to reball the chip. basically heat it, a lot of heat, a lot of flux. Make sure that the chip is liquid on all the balls and before you lift it. Once you lift it up, double check and make sure you have all the balls on the board. If you do not, if you have one ball that's gone or you know, is smaller than the rest, then you need to start over and you need to reball the chip. But if you do it like I did and wait until they're liquid and pull straight up on it, you should have no need to reball this chip. This is a donor board I showed you, but this board would work perfectly fine if it was on a customer's board. So that's pretty much it. If anyone has any questions at the end, put it in chat and I'd be happy to answer them. But that's pretty much it. And hopefully this video will help you, because reballing is very frustrating. But you know, hi Marway, just thank you again for the microphone you sent me. I really appreciate it. How about those chip suckers? You can if you have one. I mean, I don't personally use them. I don't have one. I just use my tweezers. So on top of that, I think I'm going to end the stream. Thank you all for watching, and I hope this video helped you. There'll be some more videos like this to come on soldering techniques and just board diagnosis and stuff like that. So thank you very much for watching, and hope this video helps you.